will introduce you to the wonderful world of vectors. You will be thrilled to join the fraternity of people who now understand vectors. You will say on a daily basis, Mr. Bennett, can we do more of that vector stuff? It's oh so much fun. Do you detect sarcasm? We're going to use them right away, Sean. Okay? All right, well, let's talk about vectors. These are notes, by the way. I apologize. Okay, so based on that 4-minute clip, what's a vector? Well, what does a vector have to have? Direction and a magnitude. And what's the other word for magnitude? Size. Okay? Size, exactly. Okay, that's good. That's really all you need to know. I'm going to see if I can kind of fill in the blanks a little bit here, but really, a vector is simply an arrow that represents a vector quantity. A little bit of a, I don't know, a little bit of a small detail, really, right? A vector quantity is something like displacement, okay? The vector is just the arrow itself. Now, did he draw an arrow? I think he drew an arrow, didn't he? Yeah, he drew an arrow there, right? But he didn't actually, he sort of just showed it as moving, right? But we are going to actually draw arrows to represent vector quantities, okay? And the length of the arrow represents the magnitude of the size of the vector. In other words, the longer the arrow, the bigger the displacement, bigger the size, bigger the magnitude, right? The length of the arrow. And obviously, but it needs to be said, the direction that the arrow points represents the direction of the vector quantity. In that case there, the arrow points to the right, so the vector is to the right. Okay? Now, one small little thing I need to point out, I had one student many years ago, I believe it was a girl, I can't remember, but she, I'm pretty sure, she was measuring right to there because she thought that was a nice sort of thing to measure to. And she was always off by about 3 millimeters. How come? It's right to the point, okay? So you have to measure right to the arrow point, okay? You can't just sort of measure right to there. Most people don't draw their arrows like that. Most people just draw them like that, right? Very few people will take the time to color that in, okay? But you measure right to the point. Now, that sort of brings up another topic, is she was off by about 3 millimeters. Now, you might say, well, Mr. Bennett, if I'm using a ruler, you know, my ruler might be slightly off. Or if I'm using a protractor, which is going to be, I might be off by a little bit, is that okay? And the answer to that is yes. In the good old days of applied math, grade 12, they used to allow you to be plus or minus 3 millimeters off. That's a whole lot of room, right? So if it's supposed to be like 6.5 centimeters, you could be anywhere from 6.2 to 6.8. If you can't be within that range, you're wrong, right? Like no one's ever off by 4 millimeters. Okay, they're off by like 4 centimeters. Same thing with the degrees, plus or minus 3 degrees. All right. So, what are some of these vector quantities? Well, you've probably heard of some of them. Vector quantities are quantities that have direction associated with them, as they said in the video, right? So, vector quantities must have a direction. The big four common examples are displacement, velocity, acceleration, and force. Displacement, velocity, acceleration, force. There are others. You're going to be meeting them in the next 2 years, but those are sort of the big four. The opposite are scalars. Scalars are quantities that do not have a direction associated with them. There are hundreds of examples of those. Things like mass, time, cost, anything that sounds weird when you put a direction in front of it. How much did your phone cost? $247 north. If it sounds weird with a direction in it, it's a scalar. How old are you? 17 years old, south. So with your clicker, tell me, which of the following properties in physics do you think is a vector? Speed, density, momentum, or volume? Okay, so how did we do? Well, the correct answer is C, momentum. Momentum. It can't be speed because the vector version of speed is velocity. Density is like 47 grams per cubic centimeter north. That makes sense. Momentum has a direction, right? If I run into Sean, I have a certain momentum in that direction. Volume is just like a liter or some other cubic centimeters, right? So the correct answer, yes, is C, momentum. Okay. Because speed is actually just the speed. Velocity is speed plus the direction. The vector version of speed is velocity. Okay, next question. Which of the following properties in physics do you think is a scalar? Gravitational field strength, density, magnetic field strength, or torque? You've got a phone in your pocket. All right, well, if you were listening carefully and paying attention, you would have known that density was on the list before, right? And so therefore, if it wasn't a vector, it must be a scalar. Gravitational field strength, which way does gravity point? Down. Always has a direction down. Density is a scalar. Magnetic field strength is always from north to south, right? There's a direction of the magnetic field. And torque is like a twisting kind of force thing. So it's kind of like clockwise and counterclockwise. And I wouldn't expect you to know that. That's okay. No worries. Okay. So, how do we draw a vector? Let's talk about sort of some things here, okay? Vectors are represented algebraically. When you're writing a vector, like in a math kind of equation, it's written with a variable with an arrow over it, such as this one for velocity, okay? You would write a v with an arrow over it, and usually we just tend to put the one part of the arrowhead, okay? So that would indicate a vector, that kind of thing. In the old days, before desktop publishing and stuff, books were printed, they would put the letter in bold and italics, and that would indicate that it's a vector. But now, almost all the time, you're going to see with the arrow above. Like way too much. Okay. One thing you will learn in here is you do not need to write everything on the slide. The note police are not going to come and arrest you because you've not written everything down. I know I need to untrain some of you. It's going to be a real challenge for some of you. Stop doing it. When representing a vector graphically, in other words, when drawing the picture, you can move the vector any way you like. It can be anywhere on the page as long as two things remain the same. The length and the direction. The length and the direction must remain the same. It can be anywhere. And here's an example. Two vectors shown below are considered equal, even though they do not have the same starting points. I have vector x and vector y there, okay, but they would be equal. How come? Because they point in exactly the same direction, they have the same angle, and they are the same length. It is exactly the same principle as this. That's a poor one. Those are equal. They're in different places, different colors, different font, but they mean the same thing. Okay? So two vectors can be anywhere on the page, okay, and they are equal. Now that might seem kind of obvious, but it's kind of one of those presuppositions that I need to tell you about, one of those assumptions. Okay, again, you don't need to write everything. Read it, summarize it in your words, and put that on paper. And if you say I can't do that, you're wrong, because you're going to have to do it. Word. The unit of the magnitude, because some people quite often be, well, what units do I use for vectors, okay? There's not a specific unit for vectors. The unit of the magnitude of a vector depends on the type of vector you're representing. For example, displacement vector would be measured in meters or centimeters or miles or whatever, kilometers. Velocity vector would be meters per second, kilometers per hour, and so on. So in other words, what you could write down is there is no specific unit for vectors. You just use the vector, the unit for that quantity. Okay, so there's no specific unit for a vector. Now, direction of vectors. Okay, now direction of vectors, that's a whole different ballgame, okay? The direction of vectors is kind of complicated. In fact, there's more than one way to talk about the direction of vectors. You've already actually dealt with vectors in grade 10 when we dealt with positive being to the right and negative being to the left. So you've dealt with sort of like one-dimensional vectors. We didn't talk about right and left, we just talked about positive and negative, right? But what if it's up and down? What if it's somewhere between up and down and right and left, right? Okay, so you got to deal with all that. So I'm going to start you off with an easy one. A man is following a scavenger hunt. It's a ridiculously simple scavenger hunt. He is to walk plus 35 meters and then minus 10 meters. What could this possibly mean? 35 meters forward, turn around, 10 meters back.
25 meters forward.
20, in other words, a resultant, if I could use that word, of 25 meters, right? Plus 25 meters. Do you really need to write that example down? No. You sure don't. This one, you might want to write down. An airplane is traveling at 200 kilometers per hour at 40 degrees south of east or east 40 south. This one you want to write down. Sonia asked, is south of east the same as southeast? Good question. Before I get into actually this here, let me just show you that. I'll make myself some room here. I'm sure you are familiar with north, east, south, west, right? Everybody knows that? Right? Never eat soggy wieners. Did you know that the 6 o'clock news is because the information comes from north, east, west, and south?
I didn't catch that.
The 6 o'clock news is because the information comes from north, east, west, and south. News. Now, believe it or not, most people know north and south. East and west, usually once a year I get someone getting them backwards. I don't know how. It happens. Okay? So Sonia's question is south of east mean the same thing as southeast? And the answer to that is no. Southeast means exactly 45 degrees. South of east. Exactly 45 degrees. Okay? And there's actually something that they call south-southeast, which is exactly between south and southeast, which would be 22.5 degrees. Well, I'm not going to worry about that. All right, so how am I going to draw 200 kilometers an hour at 40 degrees south of east? Well, this is what that means. South of east, okay? So the first thing I'm going to draw is I'm going to draw south or east, do you think?
East.
East, very good, Larissa. I'm going to go east. Okay, so I've drawn east. Now I want to go south of east, and so my line is going to be like that. That is south of east. South of east.
That's exactly what you just wrote. You said it was southeast.
But in this case here, it's not exactly 45. This one is 40 degrees. Good point, though. It has to be exactly 40. That's right. If I just say southeast, then that southeast is equivalent to 45 degrees south of east.
So it's southeast, but with the degrees that's specified in the
Right.
question.
Yeah, that's correct.
So then what if it's greater than 45 degrees or southeast?
No. Then you would just say like 60 degrees south of east. Southeast means exactly. Well, it would be 45 plus 22.5, right? 67.5. Don't worry about southeast. Don't worry about that. Okay, so 40 degrees south of east. Now, the other way to write that would be, this is 40 degrees south of east. You could also write east 40 south. Most students prefer this method because they say, Mr. Bennett, I don't get this. It's 40 south of east. You have to start at the back first, right? Like you got to start with the east, and then you go 40 degrees, and then you do the south, right? East, 40 south. Most people prefer this way. I look east. I'm reading it from left to right. East, 40 degrees to the south. Most people prefer this way.
Okay, so can it also be like east of north?
It could be, but yeah, it's not.
Would it be the same thing though?
Well,
Are
No,
you gonna-
well, east of north would look like this, right? That would be north.
No, I get the whole thingamajig, but are we using like east of north and north of west?
Mhm. Yeah, that's just example number one, that's all. Okay, just example number one. Okay, so with the clickers, oh, is this a clicker question? Is a 90% of you got it right. Good for you. All right, 30 degrees north of east. This is east. 30 degrees to the north, right? What would this one be if that was 30 degrees? This would be
30 degrees.
east of north or north 30 east. And this one is east 30 north. Good. Okay, now, there is now a third method for talking about directions. Now, this is the actual method used in the real world. Okay? Yeah, I would do this one, yeah. When you are flying a plane, right, or even if you're watching a movie and they talk about flying planes and they say, give what you're heading or what you're bearing, this is what they're talking about. Okay, what you're bearing. So I've got a sailboat moving at a bearing of 210. Generally, the bearings are placed in the square brackets, and sometimes there is no little degree sign. So it's just a square bracket thingy. It's always 3 numbers. Okay? So here we've got a bearing of 210. This method assumes 0, 0, 0 is north, and it revolves clockwise. Okay? And so you need to have this drawn. So this is 0, 0, 0. This is going to be 0, 9, 0. This is 180. And this one, of course, is 270. Now, the reason that pilots use this, guys that sail boats use this as well, is because they don't have to think north of east. You know, it's kind of confusing, right? If you know this, 0 is north, and you just, once you get that sort of memorized, you know exactly what direction it is, right? Air traffic controllers use this as well. Okay, so what would be 210? Which way would 210 be? Well, obviously it's got to be between 180 and 270, wouldn't it, right? So it would be down there. And Nick, what would this angle be in there? If the red arrow is at a bearing of 210, what angle would that be between the south and the vector? How'd you get 30? Exactly. Right? 210 minus 180. Okay? Now, just so you know, none of you are probably in math taking the unit circle yet, right?
Yeah.
Unit circle?
Yeah.
Okay. You might get confused because the mathematicians, they start their thing at 0 there, and they go this way.
Yeah.
Stupid math people.
So dumb. Yeah.
There's a reason for it. Okay? But this is unrelated to that. Okay? So 210 is that direction. Okay, so guess what I'm going to do? I'm going to ask you a clicker question right now. Which vector is at a bearing of 300?
I can't see all those answers.
Gee, which direction could it be? Which vector is at a bearing of 300? Now, how many people like drawing scale drawings in maybe grade 7 or 8 math? Maybe even grade 9 math, I don't know what the scale drawings are in, right? Well, vectors are drawn by scale drawing. So scale drawings are often used to represent vectors. For example, a vector of 300 newtons down could be shown as. Now, there's 3 parts to the scale drawing. The first one, which is the part that everyone screws up, is the most important in my mind. You have to give the scale, like 1 centimeter equals. Now, listen carefully. The scale always, and I don't always use the word always because it's a dangerous word, because it means, with no exception, always use 1 centimeter equals first. Okay? You could, on some occasions, write 1 millimeter equals if you want, but it's always 1 centimeter. In this case here, I would say something like 1 centimeter equals 50 newtons. In other words, every centimeter of distance represents 50 newtons of force. Okay? You do not write 50 newtons equals 1 centimeter. That is incorrect. Okay? 1 centimeter equals 50 newtons. And if it's straight down, so how am I going to draw this? Well, I'm going to draw a line straight down. That's how long? 6 centimeters long. I get a ruler and I draw a line 6 centimeters long, straight down. Yeah, makes sense? Right? Okay, so you're going to have to be able to draw scale drawings of vectors. It's pretty easy. Good? Okay, so I would like you to, you've got about, let me see here, about 10, 12 minutes, 15 minutes, something like that. I would like you to draw scale drawings of the following vectors. I'm going to leave those up on the board. I've got